Oh, hey there folks, it's Dr. Franklin and I am providing you with a video tutorial that will walk you through how you can calculate the two-sample t-test within the statistical package for social sciences. If you don't already have the virtual computer lab open so that you can access SPSS, make sure you do that before watching this video so that you can be able to follow along with me. If you can't access the virtual computer lab because of your device, then make sure you get into a computer lab on campus and access a computer that has the SPSS software on it. So I will start by going through the steps that are listed in your assignment. And if you have your assignment open, you see that you have two different groups. So these groups differ across gender. You have a group of males and you have a group of females, and then you have number of siblings listed under each of those group heading columns. So with SPSS open, you are supposed to do the following. First thing that you want to do is go to variable view. You'll know that you're at variable view because that tab will be aglow at the lower left hand side of your screen. From there, go to your first row and enter gender. Ultimately, we're dealing with two different groups that are differentiated by gender, so that's going to be the name of our first variable. The name for our second variable will be siblings because we will be assessing significant differences in siblings across gender. Okay. So notice that all of the other column headers are pre-populated, and your steps within your assignment have you going through each of these column headers. You don't need to make any changes to type because we will be entering in numerical data, but you do have options to select other types of data that exist out there. We don't need to make any adjustments to width or decimals since we are going to be inserting single digits only. If we had numbers that were rather large, getting up into the billions, we can make some adjustments with width. If we had a desire to ensure that our variables were set up just to handle the single digits, we could actually take things down to 1 in width and remove the decimals. I'm just going to leave it as is because it's pretty simple and straightforward what we'll be doing here. Now, moving over to the label column, this is a place where you can write an extended name for your variable. There may be some instances where you just simply repeat what is said in your name header, and then there may be some instances where you desire to extend out the label for a better description of the variable. So in the label section, you can actually enter spaces as you've seen me do there, and because of the device I'm using and how sensitive it is, it has created another set of variables for me that I don't necessarily need. So let me see if I can remove this. And I just right clicked, went down to clear, and it removed it. Now moving on, values. Under values, you can assign labels that are associated with certain numbers if you need to for your variable. If you have a nominal variable, you should be doing this. Gender is definitely a nominal variable, so we'll want to utilize the values header for it. And let's make one males and 2 females. So this is me simply duplicating what you'll see in your SPSS assignment, but keep in mind that you don't have to go with 1s or 2s. You could choose any number, 25 males, 27 females. So you can choose any numeric to differentiate your variables within your variable view setup. The important thing is you want to make sure that there is consistency across variable view and data view. So whatever you put in variable view is representing a particular group. Make sure you're using that numeric when you go over to data view. You'll see that later on once we get to that point in the video. In terms of values for siblings, we don't need to enter anything there because we're dealing with ratio data. Missing column is a place where you can insert an arbitrary number to account for missing data or questions that a participant perhaps did not answer. This ensures that zeros don't inaccurately get put into the SPSS statistic that you're running and cause a skewing of the results. We don't have any missing data, so you don't have to worry about that particular column header. We can leave columns alone. We can leave the alignment alone. With measure, we will want to make sure that we're selecting the proper measure for each variable. We're dealing with the nominal variable in terms of gender, so we select nominal. And then with siblings, because this is a ratio variable, we will select scale, since scale is used as the label for interval and ratio data. All right, so with that, we are done setting up our variables. Let's toggle back over to data view. All right, so now we're at the point of inputting our data into SPSS. Now we said that 1 represented males, so for the first participant I enter, I'm going to indicate that he's a male by 1, what I used as the defining number for males in my variable view setup. And based on the data in the SPSS assignment, he has 4 siblings, so I will enter in a 4 next to that 1. So participant 1, again, is a male, has 4 siblings. Okay, and you will do that for every piece of data that is in your data set. We have 16 pieces of data that we need to enter. There are 8 males and there are 8 females, so you should have 8 ones, 8 twos in the gender section, and then you should have all the other sibling related data connected to each participant right beside your gender indication. So just for the sake of speed, let me just enter 8 ones and 8 twos. Four, 3, 2, 5, 1, 1, 4, 3, 7, 8, 5, 4, 7, 6, 8. All right, so all of our data is in SPSS. Now from here, you will click Analyze, go down to Compare Means, because that's what we're essentially doing. We're comparing the average amount of siblings for males to the average amount of siblings for females. We'll go to Independent Samples T-Test. And once we're here, we will highlight Siblings of Hampton Roads. This is the test variable. And we will move that over into our test variable section. Next thing we'll do is highlight the categorical variable or gender and move that over into our grouping variable section. Now you're almost done. The next thing that you need to do is click on Define Groups. Once you click on Define Groups, you won't see this pre-populated like it is now, but instead you'll have to input the numbers. We have a 1 and we have a 2 representing group 1 and group 2. So you'll want to make sure that you input in for group 1, and for group 2, number of 2. Click on Continue. I didn't click the right numeric. All right, group 2. Got that 2 in there. Then we click Continue. Okay, then click OK. All right. So now that you've clicked OK, you have some group statistics and you have an independent samples t-test statistic that has been ran. So at the top you see that there are 8 males and 8 females in your study. And on average, there are 3 siblings that the males have. On average, there are 6 siblings that the females have. So we see a difference that's existing already. The standard deviation is smaller for males than it is for females, and we see that the standard error of the mean is smaller for males than it is for females. Moving down, we have the independent samples t-test, and the first thing that you see calculated is the Levene's test for the equality of variances. A variance is the average squared distance that a score is away from the mean, and this statistic is calculated to ensure that there are no extreme differences in terms of variation across the groups. If there are extreme variations, then this can alter your t-statistic. So a f-test is ultimately calculated, and if this significance column is below 0.05, then it is significant, and you cannot use this first row to interpret your t-statistic. So again, if this equal variances assumed statistic is below 0.05, then there's a violation of sorts in terms of the equality of the variances, and you can't go with that first row, but you have to jump down here and use this t-statistic. Essentially, there's an adjustment made to ensure that things are balanced out in terms of variability when the t-test is being calculated. We're okay because this is at a 0.554. It's not significant, so we can move forward and interpret this t. We see that the t is a negative 3.55. The degree of freedom is 14. So if we were to take one from each of these respective samples and then add up the resulting figures, we'd get 14. And we see that our t-statistic is significant in that it is below 0.05 and 0.01 for that matter, and that there is a significant difference in siblings of Hampton Roads across males and females. So with that being said, I will stop this tutorial, and I hope that it was extremely helpful. Let me know if you have any questions, comments, or concerns, and I look forward to interacting with you soon.